Hello, Chem 110. This video is about how to calculate molarity, which is the most common way chemists use to describe the concentration of a solution. So start just with some basic definitions. So molarity is defined as moles of solute, that's the thing you're dissolving, over liters of your solution. And we use an abbreviation for this, which is big M. So I'm going to start with an example of a solution of a molecular solute, something that doesn't break apart when it dissolves. And I'm going to start with ethylene glycol, which is C2H6O2. Just so you know, that's ethylene glycol. You might know this as antifreeze. I think we don't typically use it as antifreeze anymore because it's very sweet and also poisonous to pets. So pets would drink it and then bad things would happen to them. Okay, so if I have a solution that includes 0.25 mole of my solute dissolved in 100 milliliters of solution. And no, we don't say dissolved in 100 milliliters of water. The final volume of the solution is 100 milliliters, and that's how molarity is defined. We don't necessarily know that it took exactly 100 milliliters of water to do that, and that's something I can talk a little bit more about in person if you're curious. So, okay, so I could say, what is the concentration of ethylene glycol? And here's how we write that. We say, what is square brackets ethylene glycol? And I'll just write in parentheses, this is another definitional thing, square brackets of A means the molarity of A. So that's an abbreviation we use. So if I say, what is square brackets of ethylene glycol, I'm asking you to calculate the molarity. And so I think the first thing to do is to write that out, that square brackets, ethylene glycol, molarity of ethylene glycol, I'm asking you to tell me the moles of ethylene glycol divided by the liters of solution, which I abbreviate that way. Okay, so this problem, the molarity is 0.25 mole ethylene glycol divided by 100 milliliters of solution. And I have to have liters of solution, so I need to convert this. And there's a couple ways to do it. That's one way you can do it, is to write the conversion factor explicitly. So go ahead and calculate that while I let my cats out of the room where I'm recording. Okay, so now my cats have escaped and will stop clawing at the door. And if you calculate this, hopefully you ended up with the answer 2.5, and your units are moles over liter, or as we more commonly write, big M. And you would say this as 2.5 molar is what you would say, but you write 2.5 M. I want to say just another thing about, so converting milliliters to liters, we very often, not always, use milliliters in lab instead of liters. Sometimes we make a liter of solution or even bigger ones, but usually we make smaller amounts. We have to convert our milliliters to liters. We can do it the way I just outlined here. You just have to be careful. You know what your calculator thinks you're doing when you divide by something that's in a denominator. Another way is to take a number like 100.0 milliliters. Because milliliters are 10 to the minus third liters, I have to move the decimal point 3 places to the left to make liter. So it becomes that in liters. This is the way I normally do it. I'm going to do that in the rest of this video, but you should do it whatever way makes sense to you. Okay, so another example is, because in fact, usually we don't measure things in moles, we measure them in other ways. So another question is, if I dissolve 0.25 grams of ethylene glycol in water, unless otherwise stated, we assume our solvent is water. It doesn't really matter for the calculation. To make 100 milliliters of solution, what is the concentration of ethylene glycol in that solution? You're welcome to try this on your own. Pause the video and come back, and I'll show you my solution. So to do this, I do need the molar mass of ethylene glycol. I'm not going to go through that calculation here. Hopefully I got it correct. If not, you can tell me. But I got 62.08 grams per mole. So again, to do this calculation, I like to write out that what I want, the concentration of ethylene glycol, is equal to the moles of ethylene glycol divided by liters of solution. I just like to remind myself that before the calculation. Liters of solution is pretty straightforward. It's 100 milliliters, which again becomes 0.1000 liters. Please leave all the significant figures in there so you don't forget about them. And the moles up top, this is its own little dimensional analysis calculation. I have 0.25 grams times 1 mole of ethylene glycol is 62.08 grams. And that calculation gives me, with 2 sig figs because of the 0.025 grams, 0.040 molar. Okay, so this is not a dimensional analysis that's a starting point, ending point kind of problem. In molarity, you're always calculating a ratio. You're calculating moles on the top and dividing it by liters on the bottom. Okay, so I just want to give another example of a different kind of compound, which is, so here we looked at a molecular solute, ethylene glycol, that does not break apart. We can also calculate molarity for ionic solutes, and ionic solutes do break apart. So an example of a solution with an ionic solute. So I'm going to use sodium carbonate, Na2CO3. When you dissolve this in water, aqueous, it breaks apart. The subscript becomes a coefficient. The ion is Na plus, not Na2. So it's 2, but you have 2 of them, 2 Na plus carbonate, which has a charge of -2. From Chem 111, you should know for sure that Na is Na plus if you're taking that, but you can look it up if you're not in Chem 111. In carbonate, you just have to know / look up that it has the charge, although once you know sodium is +1, you can see that the 2 makes a total of +2 charge, so the carbonate must be -2. Okay, so we can calculate concentration of sodium carbonate the same way we do with a molecular solute, but we can also do something else. So for example, if I have a solution where the concentration of sodium carbonate is equal to 0.150 molar, I might be interested actually in the concentration of a particular ion. So for instance, what is the concentration of sodium plus? Or maybe I want to know the concentration of carbonate. So here's how you do this. So for instance, if I want to know the concentration of sodium plus, again, I want to remind myself that I want the moles of Na plus divided by liters of solution. Now here, I don't know exactly how many moles I have or how many liters, but I do know that I have 0.150 mole of sodium carbonate per liter of solution, because that's, in fact, what this means. And to convert that to moles of sodium plus, the bottom is all set. I need to look at my dissolution equation here, or you can just look at the chemical formula and see that for every 1 mole of sodium carbonate, oops, I have 2 moles of sodium plus. So I do that calculation and I find out that the concentration of sodium plus is twice the concentration of sodium carbonate. It's 0.3 molar, 0.300 with sig figs. So if you do the same thing for carbonate, it has a 1-to-1 ratio. You can write out this same calculation, or you are allowed to just look at it and see, oh, there's a 1-to-1 ratio in that compound. So in fact, the concentration of carbonate is 0.15 molar. So I'll end with one more problem for you to do, and you can stop the video to do it. What is the concentration of the sodium ion if I dissolve 0.43 grams sodium carbonate in a solution that is 250 milliliters? So you're welcome to pause the video. You can come back and see how to answer this if you're not sure, or you can check your answer. Okay, so I want to calculate the concentration of sodium, so I start out by reminding myself I want to end up with moles of sodium plus divided by liters of solution. And so I'm sort of prepared for a slightly longer calculation up top. The liters of solution is 250 milliliters, so 1, 2, 3. 0.2500 liters solution on the bottom. That part's done. I just need to calculate the moles of sodium chloride. So the top is its own dimensional analysis problem with a starting point of 0.43 grams sodium carbonate. Now you're going to need the molar mass of sodium carbonate. Again, I'm not calculating that out here. I did it on my own, and hopefully I did it correctly. So 1 mole of sodium carbonate is, by my calculation, 105.99 grams. Okay, so that will get me to moles of sodium carbonate, and then again, I need that ratio that I have 2 moles of Na plus for every 1 mole of sodium carbonate. So now I'm all set. I'll just show you that my units will cancel out. I have grams sodium carbonate, moles sodium carbonate, and I end up with moles of sodium over liters of solution. And the final answer I got was 0.032 molar is the concentration of sodium plus. I have 2 sig figs because I was limited by my 2 sig figs here.